can see, what you can see right there on the board is the topic, a follow-up of the video I've made earlier on indices. And for what you can see right there on the board, we are dealing with equations of indices. Very simple. There are two aspects of equation of indices I would like to talk about. The first one is when the unknown is at the base. I will give you an example of that. Example now, this is unknown. It's having 1/2 equal to 4. Whenever we have something like this, the first thing we do, like we always talk about equations. In equations, we look for a way, we are looking for a way to, we want to look for x. And the only way we can look for x is to remove that power from x, which is 1/2. The best way of doing it is to look for the inverse of what you have here, which is going to be 2/1. You use it to multiply the power of both sides. Use it to multiply the power of both sides. So we now have 1/2, the power of both sides, multiply the power of both sides with that power. So now 4, 2/1. As both sides of the equation, you will see that I use the inverse of what is there. The reason why I'm doing that is that I want to remove this power from 2. When we see that, you see that this one will cancel out. So now I have x 1/1. Now I have x raised to the power 1, which is the same thing as x. We don't normally write it like that in mathematics. So what we now have here is 4. 2/1 is the same thing as 2. So we now write it like this. So 4 raised to the power 2. We know it means that it is 4 times 4 that gave us 4 raised to the power 2. So we now say is what? 16. So you can see that from what we are having here on the board, we've been able to look for the value of x. We call it equation in indices. And also what you need to know here is that in some mathematicians, when they are teaching you something like this, they will just tell you that when you find a square root on this side, because from our sixth law of indices, this one means square root of x. They will tell you that when the square root will cross to become a square on this other side. This is what I'm saying, talking about 1/2 raised to the power 4. On this side is a square root. On this other side, the opposite of the square root becomes what? Square. They will just say it's equal to 4 raised to the power what? 2. That is on this side, square root. On this other side, it becomes square. The same thing for cube root, the same thing for fourth root, and all the like. But I am trying to explain what really happened there. What made it to be like that. That's why I went through this process. But if you know that this one is difficult for you to know, but it's good you know this because other questions will test your ability on this. So I will advise you know how to use the inverse of the power to cancel out, to know what will be the outcome on the other side of the equation. That is example 1. Example 1. I will come up with other examples for us to explain properly what we are talking about. Let me go to example 2. Example 2. Let me see, this came around and let me see x raised to the power 2 is equal to 4. I'm using 4 in both cases so that you understand what is really happening. Now, we are having x raised to the power 2 and we are looking for x. What do we do to remove that power of 2 from x? The only thing we can do here is to look for the inverse of that 2, which will now be 1/2, the opposite, like 1/2. We'll now see x raised to the power O in bracket 1/2 equal to 4 raised to the power 1/2. What we have done is that we've taken a decision that we are using the inverse of 2, which is 1/2. And that 1/2, the 1/2 We'll cancel both. I mean, we multiply the power with 1 over 2 in both sides. You can see that this one will cancel out. When it cancels out, so we're now having x, because it's 1 over 1 that will be there. X will now be x will now be equal to 4 raised to power 1 over 2. 4 raised to power 1 over 2. That is what you are going to have there. And we know that the meaning of this is actually square root 4 from the sixth law of indices that we did in our previous video. The square root of 4 is equal to 2. So x is equal to 2. X is equal to 2. So we have gotten that. That's exactly what you expect in questions like this. Other examples we are going to do here are example 3, for instance. I will give you other questions like, okay, let me see, x raised to power minus 2 is equal to 4. All you just need to do is that, in this case, we look for how to remove this minus sign and also how to remove the 2. So it's just the inverse like we did earlier in the previous calculation. We are using the inverse, and this time around we are going to introduce minus also, because minus divide minus is actually plus. Where you need to multiply minus times minus, you can also apply it there, but in this case we are using minus divide minus. So what we are going to do is going to say x raised to power minus 1 over 2, then multiply it by minus 1 over 2, both sides. But what you are doing to one side of the equation, you do it to the other side of the equation. Mind you, don't forget, we are dealing with the power. So we are multiplying the powers with minus 1 over 2, because the inverse of this minus 2 is actually minus 1 over 2. You see the reason why we did it like that. Minus times minus will give us what? Plus. You can see, because we need to use it to open the bracket. Then 2 will cancel 2. Automatically we have come back to x, which is because x raised to power 1. X 4 raised to power minus 1 over 2. You can see. Then you are going to apply your fourth law of indices that we did in our previous video. That fourth law of indices, what it states that you are going to say 1 over this number. This is the number. We are removing the minus sign at this time. Check the video, you will see the explanation there. We've done that before. So then we go further. 1 over, this one is now the sixth law of indices, that is 4 raised to power 1 over 2, which means square root of 4. So now 1 over 2 as our answer. All of these things, you can get them when you subject questions like this to AI or any of these ChatGPT and other platform. But I think it's best you understand the breakdown principles of these calculations. That's the reason for this video. Otherwise, when you subject the questions, you can get the solutions. But it's good you understand what is really going on there. So I will solve other questions. Example 4. In example 4, I'm going to give you n raised to the power minus 2 over 3. Okay, let me just say 2 over 3 first before we go into that minus 2 over 3. Or let me say, should I say 3 over 2 rather, equal to 8. 3 over 2. This is a question that we can solve. But mind you, like we've always been saying, you need to get the inverse. We are looking for n. We are not looking for n raised to the power 3 over 2. We need to get the inverse of this. And the inverse of this is going to be 2 over 3, which you use to multiply the power of both sides. And 3 over 2, or in bracket 2 over 3 equal to what? 8. 2 over 3. This is exactly what you're going to have. 3 will cancel 3, 2 will cancel 2. So we now have n is equal to 8 raised to the power 2 over 3. And we know fully well that this one is our seventh law of indices, where n is equal to square cube root 8 raised to the power 2. If you are having problem with what you are seeing here, go to my previous video on indices. I have indices 1, I have indices 2. I have actually explained in a very clear terms the first law to the third law, and the fourth to the seventh law. I made it very clear in those previous videos. So check it very well. You see that you understand what is happening here. So we now have the cube root of 8 is actually 2 raised to the power 2, because we've used this cube root sign. That's why we didn't include it there again. Then now see raised to the power 2 is now equal to what? 4, because 2 raised to the power 2 is actually 2 times 2, which makes it 4. I think this is the first aspect of the questions where we have the unknown as the base number. But there are other aspects where the unknown will not be at the power. We are going to those kind of questions now. So you try to understand what is happening here. Example 5. In these kind of questions, you're going to see that the power will not be the unknown, unlike this case where the base is the unknown. Okay, let me give you something like, okay, let me just say 2 raised to the power x equal to 8. In this case, you will see that example 5, example 5 or example 6, okay, example 5. So let me just see. So in this case, what we normally do is that we try to raise all the powers to the same base, because it's possible for us to raise 8 to the same base of 2. You can see that we can calculate for it. Then so now say 2 raised to the power x is equal to 2 raised to the power. So whenever you see questions like this where the power is, where the unknown is in the power, this is what your mind should always go to raise it so that everything will not be in the same base. Your mind should always go to this direction. There is no other way to it, except if there is no way you will not go to what we call logarithms. Now use logarithm to do our evaluation. But this is exactly what you expect. This is 2 raised to the power 3, which is exactly 8, an equivalent of 8. So the base cancels the base, so now our x equal to what? 3. You can see we've gotten our unknown as 3. Then we have example 6, where we talk about, okay, let me just look for other questions like, okay, let me say 9y equal to 27. There are more and more questions you can solve. I will create a platform where questions can be asked and solve those questions together. Now, what we have here is going to be, we are going to raise this one in such a way that both of them will have the same things. And the only way we can do that is we're going to say 3 raised to the power 2y, that is 3 raised to the power 2, the y was there before. And this one is 3 raised to the power 3. 3 raised to the power 2 is actually 9. 3 raised to the power 3 is actually 27. So that is where we are coming from. There should be a progression as you go onward. As you go, 3 will cancel 3, so now 2y equal to 3. When you go back to our simple equation principle, we know how to look for y. In case you don't know what should be done here, you check my video on simple equation. You see what should be done here. Divide both sides by 2. So y is equal to 3 over 2. So we've gotten y as 3 over 2. So this is just a simple concept for knowing an equation of indices where the power, the unknown is the power. That is exactly, we have more complex questions than this, but this one is just kind of eye-opener, like just get a clear picture of how it goes. All you just need to do is to raise it to that power of raise it to the same base number. Let me just throw one question here. You see, for example, now we have 3x equal to 1. Yes, this one can look a little bit confusing. but it's very simple. What has happened here is that we know that anything raised to the power 0 is equal to 1. So we can also raise it to the power of 3, knowing fully well that 3 raised to the power 0 is equal to what? 1. So we put the equivalent there, we don't change it. You can see 3 raised to the power 0 is equal to 1. And we know fully well that in the place of 1, we can put what? 3 raised to the power 0. That's what we have done. Very simple. X is equal to what? 0. I've gotten the X. So, whatever way it comes, especially when you see questions like this and it's equal to 1, please bear in mind that if it is 4, you know that you're going to raise it to power of 4, 4 raised to the power 0. If it is 5, 5 raised to the power 0, because all of them will give you 1. Because anything raised to the power 0 is equal to what? 1. A very simple concept. There are cases where the base number you're going to raise it to, I think I saw some questions like that in essential mathematics, where the base can be a fraction. That is not a problem. You just know that, okay, this is the base. You raise it to that power. You raise it to the base, I mean the power, such a way that you will not be having the same base in both sides of the equation, where you can cancel out. The power will not give you the unknown you are looking for. It's just a simple concept. It doesn't change. It's just a simple concept you need to take note of. Bringing it to the same base, and you cancel out the base, then you get your answer, you get your no as the answer. So that is exactly what is expected of you. Thank you for joining us in this section of mathematics. I think with this, if you do your calculations and you work on it, you are good to go with any calculation that has to do with indices. We will give you other videos that has to do with other aspects of indices shortly. Just follow us on our channels. Thank you very much.